This section is over complex numbers. So complex numbers are also known as imaginary numbers. This one, it starts with the question, which of the following is the principal square root of -4? So pretty much imaginary numbers came about because people were solving problems and were like, there's this whole nother set of numbers that we're not using because they're not real. So let's call them complex and start graphing them. Essentially, that's what happened. So they have options on this one. Our first option is -2. Our second option is +2. This one is -2i, and then we have 2i. So when we take the square root of something, it can never be negative, because if we square something, it's not a negative. If I squared like negative, we'll do 2. We'll stick with 2. If I square -2, I'd have -2 times -2. A negative times a negative makes it positive, and 2 times 2 is 4. So that's why if I took the square root of a -2, I'm not going to get a negative. All of this comes down to say that the square root of a -1 is an I. It's our imaginary number, I. So when I take the square root of -4, I get 2i. Just know you will never have a negative, an actual negative, come out of a square root. You'll get an I. That's a trick question. I think there is one on your test that's similar to this, like the square root of a negative, the two problems that have the negatives with it, it's wrong. Don't mark those. So we treat our I like an X when we're adding and subtracting. You can combine things that have I's, you can multiply I's together. But when we write these, unlike our X's, we always had like X squared, X constant. I always goes at the end. The form they want us to write imaginary numbers in is A plus BI, where our real number's at the beginning and I is always at the end. So our first problem is 7 subtract 4i plus 5 plus 9i. So we treat our I just like an X when we're adding and subtracting. We're combining like terms still. So I have 7 plus 5, which is 7, 8, 9, 10, 11, 12. -4 plus 9 would be positive 5i. That's the answer. Stop there. You can't combine this I with them. That's just it. Remember, I goes at the end. The next problem they have, -4 plus 4i, subtract 8, subtract 7i. So just like if this was an X, we distribute this negative right here. So I'm going to have -4 plus 4i. Negative times a positive is a negative. Negative times a negative would be plus 7i. And then combine your like terms. So -4 and -8 is -12. 4 plus 7 would give us 11i. And that would be your answer. Stop there. So it's not too bad. You just have to remember, like when you're adding and subtracting, that it's just like X. So treat it like that. Just throw it at the end. When we start multiplying, though, I squared, you cannot put that in an answer. Okay, the next problem is also a subtraction problem. So we have 2 subtract 9i, subtract 5 plus 7i. So since this is a subtraction problem, I'm going to distribute this negative here to this following binomial. So a negative times a positive is a negative times a positive is a negative. Then combine like terms, so 2 subtract 5 would be -3, -9i, subtract 7i. I spent $9, I spent 7 more, so I've spent 16. That would be your answer. Here's a multiplication one. So we have 7 times 9 subtract 2i. Since we're just multiplying a constant, it's just like normal, distribute. So 7 times 9 gives us 63. 7 times -2 would be -14. And we keep our I. Okay. Erase. When we distribute with an I, things are going to change a little bit, and that's what this next problem is. So we have negative 9i times 8 plus 5i. So a negative 9 times 8 is negative 72i. Negative 9 times 5 would be negative 45. And just like x's, x times x is I squared, so I times I is I squared. So remember that I'm trying to decide where to work. I equals the square root of negative 1. So if I have an I squared, that's going to be the square root of negative 1 squared. And remember that these are inverse operations right here. So when I square a square root, I just get negative 1. Since I squared equals negative 1, I squared cannot be in an answer set because that makes it improper. We have to simplify it. So this I squared right here, we're going to substitute for negative 1. So we have negative 72i subtract 45 times negative 1. So you're never going to have anything besides just an I. Now this is correct because our negative times our negative gives us our positive 45. But remember, these all have to be in the form A plus BI. I has to go at the end. So I'm going to have 45 subtract 72i. And that would be your final answer on that problem. Okay, I'm just going to erase this part. Right, so we have 3 subtract 7i times 2 plus I. So just like our binomials before, when we would FOIL or multiply those, we're going to do the same thing here. So I'm going to have 3 times 2 is 6. 3 times a positive I would be positive 3i. Negative 7 times 2 would be negative 14. And since it's 7i, we have an I here. Negative 7i times I would be negative 7i squared. So we're going to combine our like terms here. This I squared here is going to change to negative 1. So I'm going to have 6 minus, because 3 subtract 14 is negative 11i. And then right here we're going to have negative 7 times negative 1. So 6 subtract 11i plus 7. Combine your 6 and 7, so that is 13 subtract 11i. I think I can fit the next problem over here. We have 10 plus I squared. Remember, when we have something like this that's squared, it's not just 10 squared plus I squared. It's 10 plus I times 10 plus I. So 10 times 10 is 100. 10 times I is 10i. I times 10 is 10i. And I times I is I squared. So combine your like terms and substitute your I squared. So we have 100 plus 20i minus I, because it would be plus negative 1. Combine your 100 and your subtract 1, so 99 plus 20i. The next part is going to talk about i's to different powers. So what you need to know about the i's to different powers is that it cycles in 4s. So we have our first two cycles up here, like you have I is your square root of negative 1. I squared is negative 1. There's I cubed, which would be the square root of negative 1 times the square root of negative 1 times the square root of negative 1. Which right here, these two make negative 1, and then this square root of negative 1 here is the definition of I. So I have a negative I. So I cubed is negative I. Up here for I to the first power is I. Okay. Then they have I to the fourth, which is 1, 2, 3, 4. Where these two together make negative 1. Negative 1. A negative times a negative is a positive 1. So I to the fourth power is positive 1. If we did I to the fifth power, we'd have 1, 1, and then our last square root to the negative 1 would be our I. So we'd end up back at I. Now when I say that these cycle in fours, every single one, so this would be I to the fifth, I to the sixth, I to the seventh, I to the eighth, 9, 10, 11, 12, so far and so forth. How I do this though is, so our problem is I to the negative 52. I take whatever this number is and divide it by 4. So I'm going to do 52 divided by 4. If 4 goes into it perfectly even, the answer is 1. If 4 goes into it and I get 0.25, it'd be I. If I get 0.5, it's negative 1. 0.75 is negative I, and this one is 0 because 4 goes into it evenly. So 52 divided by 4, 4 goes into 5. One time it goes into 12. 3 times, there's no decimal on this one. So the answer to this problem, because there's no decimal, is 1. If it would have been 0.5, it would have been negative 1. Would have been 0.25, it would have been I. 0.75, it would have been negative I. I know that's confusing. Email me if you get stuck. Okay, I'm going to get rid of this part now. Our next problem says I to the fifth times 1 subtract I to the fourth. Oh, maybe I shouldn't have got rid of it all. Here. I cubed equals negative I to the fourth equals 1. Okay. I'm going to work in the parentheses first on this one. So I to the fourth is 1. So I would have I to the fifth times 1 subtract 1. 1 subtract 1 is 0, and anything times 0 is 0. Next problem we have is I to the 8th plus I to the 6th minus I to the 4th, subtract I squared. So 4 goes into 8 2 times, so this one is 1. I to the 6th would be negative 1. I to the 4th is positive 1. And I squared is negative 1. So 1 plus negative 1 is 0. Negative times the negative is positive 1. And then negative 1 plus 1 is 0. So the answer is 0. The last two problems should have been at the beginning of this. The square root of a negative 49, remember the negative is an I, and the square root of 49 is 7, so 7I. And then the last one is the square root of negative 16. The negative is your I, and the square root of 16 is 4I. That's all.